Now we are having a numerical exercise, and here we are having our x and y, the two variables, and suppose x is our income and y is our consumptions. Then in our regression line, we have to regress y on x, that is, we have to regress the consumption on your income level. And getting that following data, you have to first solve obtain the linear regression of y on x using the OLS, and then you compute the coefficient of determinations, that is r squares. So having the following data, now we can estimate the alpha and beta, and we can regress y on x by using our ordinary least square methods, and then we shall determine our coefficient of determinations, that is r square. So let us have a solutions of fitting the regression lines on y on x, where we are having the data on y and x, and we have assumed that y is our consumption and x is our suppose income. Then if you regress your consumptions and income by using OLS, then we have to estimate the alpha hat and beta hat first, and then we can get the regression line. So before going to that fitted line, suppose we are having our population regression line is given by y is equal to alpha plus beta x plus our random part, that is u, and here there is our population regression lines, and from that population regression lines, we have to estimate our beta hat and alpha hat by using OLS techniques. So by using OLS techniques, our beta hat formula is that summation xi yi minus n x bar y bar by summation xi square minus n x bar squares. So to get the values of summation xi yi x bar y bar and others indicators, we have to construct this table. So here this is your given values of x, and this is your given values of y. So to estimate our beta hat, we have xi yi, summation xi yi. So we have written x y, that is xi yi. Then we require capital X square, so x square. So that x square is basically multiplication of this x, that is 80 into 80 is equal to 6400. Then to get our second solution, that is to estimate our r square. Now to fit the r square, we need beta hat square into summation small xi squares, and we require small yi squares. To get that small xi squares and yi squares, we have deviated capital X minus x bar to get our small x. So as we know, our x bar, when we have sum up all this value summation of x, that is 1700, and we have divided by that number of observation, then we get the x bar is your 170. So if you deviate the actual values of x from its mean values, then you will be having your small x, then you get the small x squares, then y is equal to capital Y minus y bar. So y bar we have calculated, that is 111, that is, if you sum up all these y values, then that is 1110, and if you divide by its number of observation, that is 10, then you are having your 111, that is your y bar. So after getting your small y, you get y squares. So first we have started by putting the values of x and y. Then we have multiplied the values of x into y. So this is your xy. So after multiplications of x into y, and if you sum up all these values, then summation of x y is equal to these values. And if you get the square of this x, then 80 to 80 is equal to our 6400. 100 into 100 is equal to 10,000. So in that way we get the values of our x squares. Now that is our small x. So small x, how have you obtained your small x? That is your x bar is your 170, and your actual x is your 80. So 80 minus 170 is equal to your minus 90. In the same fashion, that is your 100 is your actual x, and your x bar is 170. So if you get the deviations of 100 from its 170, then you are getting that is minus 7. So in that way we are getting the small x, and if you get the square of small x, that is 90 into 90, these values, 70 into 70, that is these values, and if you get the summations of then you are getting the summation small x squared is equal to 33000. Now if you get the y that you have obtained from by debiting its actual value from its mean value, so mean is 111 and your actual y is 70. So 70 minus 111 is equal to 41. 65 minus 111 is equal to 46. So in that way we have obtained our small y, and if you get the square of small y, then you are having these values, and here we have summed up there is summation y squares. So after getting all these values, now the part is to estimate. From OLS regression part, OLS techniques, we know the beta hat formula is that summation xi yi. So if you put the values of all these x and y's, then summation xi yi, that value is our 205500. So we have plotted these values, and then our n is our observation, that is size of observation is 10. Then x bar, it is our 170, so it is multiplied to 170, and y bar is our 111, so here y bar is also multiplied. Now summation capital xi squares, so capital xi squares, that is our capital X, so capital Xi square is 322000. So we have plotted these values minus your number of observation, that is 10, and your x bar square, so x bar is your 170, and we have kept the squares. So after get all these mathematical calculations, you will be getting your beta hat value. That beta hat value is this, and that is 0.509. So there is our estimated beta hat. So once you estimate your beta hat, then from your regression line you can easily find out your alpha hat, as your alpha hat value can be estimated. That is alpha hat is equal to y bar minus beta hat x bar. So y bar, we know y bar is our this value, so minus there is beta hat you have already estimated, that is 0.509 into your x bar. So x bar is your 170, so you have multiplied 170 here. So after getting all mathematical calculations, your alpha hat is equal to 24.45. so that is alpha hat is estimated, and beta hat is also estimated. Now if you plot the alpha hat and beta hat values in your regression line, then you will be getting your regression line of y on x. So here there is estimated y, that is equal to alpha hat plus beta hat x. So alpha hat value is equal to this, and beta hat value is our 0.509, and your x will be given. So this is your regression line. So that first part, there is question number A, that is complete. So here the question was obtain the regression line of y on x using OLS. So by using OLS techniques, that is our regression line of y on x. Now in second part, the question was obtain r square. So r square, by using OLS, r square formula is beta hat square into summation small xi squares divided by summation small yi square. So basically this is your explained sum of squares. In our earlier classes we have learned what is ESS and what is TSS. So this is your ESS part, and this is your TSS. So r square, we know there is ESS by TSS. So you can now calculate beta hat square, that is given. So beta hat is our 0.509. So get the square of 0.509. Summation small xi square, that is small xi square is 33000. So get the multiplications, and small yi square, so small yi square is 8890. So we plot 8890. Now getting the mathematical calculations, r square is equal to 0.9621. So 0.9621 implies that is our regression line is very fit, that is a good fit. So your regression, as you know, your r square, that r square ranges between 0 to 1. 0 to 1. So if that r square value closer to 0, then you are not having a good fit, but if it is closer to 1, you are having a good fit. So our part, in our part, that is our r square, that become 0.96 to 1, that is, it is closer to, very closer to 1. So we can say our regression fit, that is a good fit. Your r square is getting a good result. So this is all about your how to get the regression line by using OLS, how to estimate your regression coefficients, and how to get the coefficient of determination, that is r square. So for today, there is these two parts that is complete. In our next class, we shall go for blue test. What is blue? That is best linear unbiased estimator. So your OLS estimator, that is alpha and beta, that is said that they are blue, that is they are best linear unbiased estimators. So we have to prove that whether the OLS estimators or follow the blue norms or not. So in our next class, we shall derive our blue test, and we shall show how the least square estimators, they are best linear unbiased estimators. So for today, thank you.